Hello, my name's Neil Eliason, and this is House Divided, a network analysis of the Lincoln-Douglas debates. While addressing Congress during the Civil War, Abraham Lincoln said, "Fellow citizens, we cannot escape history." He was appealing to his audience to consider how their current actions would affect those in the future. It is true that our history affects the present, and we have an opportunity to gain new insights into that history due to recent improvement in processing and storage which allow us to view our past from a perspective not possible before by using new analytic techniques. One discipline that leverages these new capabilities is network science. It attempts to understand the behavior of complex systems and aims to be interdisciplinary, empirical, quantitative, and computational. One particular branch of network science is semantic network analysis. It applies network science to understand the underlying structure of language. It models words as nodes with edges drawn between words which co-occur in a language unit. An example is in the sentence, "The dog ran." The and dog and ran are nodes, and edges would be drawn between the and dog and ran. Semantic network analysis has been applied to the study of political discourse in a variety of contemporary settings, from studies of Greek elections rhetoric, libertarian and socialist Reddit feeds, Korean geopolitical rumors on Twitter, and the presence of white supremacist groups with the Twitter hashtag MAGA network. A good historical application for semantic network analysis is the Lincoln-Douglas debates, which were a series of 7 debates between the U.S. Senate candidates for Illinois in 1857. The debaters were Abraham Lincoln, who was the Republican challenger, and Stephen Douglas, who was the Democratic incumbent. Lincoln advocated for the abolition of slavery, while Douglas argued states should be able to decide whether they allowed slavery or not. These debates were significant because they highlighted the tensions between slavery and anti-slavery groups at the time, generated considerable civic involvement, and foreshadowed the conflict between these two men in the presidential race of 1860. This research aims to answer 2 questions. Does the structure of each candidate's semantic network change over the course of the debates? And are their semantic network structures related to each other? The data came from the Lincoln-Douglas debate transcripts found at the Internet Archive. They consisted of the transcripts for each debate in text file format, and the content included comments, input from the crowd, and other text that was not the actual words spoken by the candidates. Data was processed debate by debate. First, the transcriber notes were manually removed and the text cleaned and tagged based on speakers using Python. Then, the words were converted to their root proper English form, which is called lemmatization. Then stop words, which are words that do not add semantic meaning, were removed, and the whole structure was converted to 2 network graphs, one for each debater. This whole process was done for every debate. Graph topology was measured using node count, edge count, density, average degree, diameter, and average clustering coefficient. And here are definitions of those metrics. Node centrality was calculated using these metrics and their corresponding definitions. Given the difficulty of examining each word for each candidate's semantic network for each debate across 6 centrality measures, an aggregation method was employed. For each network graph, the 6 highest centrality nodes for each centrality metric were selected and ranked. Then the ranks for each word from each centrality were summed, and that number was the word's aggregated rank. Here's the distribution of the network topology metrics for Douglas. Whether the metric changed was evaluated by comparing the range to the mean. For Douglas, edge count and diameter exhibited some variability across debates. Here are the metrics plotted across debates and the significant correlations between metrics. Though there are relationships between metrics, there are not any between 2 metrics that varied across debates. We do see that for edge counts that it peaks at the 3rd debate, and that diameter's variation has an oscillating pattern. Here are the central words for Douglas across debates. And here are all of Douglas's important words in their rank, summed across all debates. State almost doubled the ranking of the next nearest word, say. Lincoln and make followed close behind. Here are the significant correlations between word ranks. We can see there was a strong positive relationship between Trumbull and state and between right and people, while there was a strong negative relationship between slavery and make and between right and Lincoln. Here we have each word's rank plotted across all debates. We see that state was the top ranked word for Douglas in all debates, but the fourth where it was third. Lincoln was important in the first 4 debates, but not after, and people, right, and slavery became important after the 4th debate. Overall, we saw that edge counts and diameter varied across debates for Douglas, that state was the most central word across all debates, except for Trumbull in the 4th debate, and that after the 4th debate, Lincoln was not important, and slavery, right, and people were. Here is Lincoln's topology metric distribution. We can see that average clustering, diameter, density, and edges have some variability across debates. By examining metrics across debates plot and the correlation between metrics, we see that density and average clustering varied and were positively correlated across debates, peaking at the 4th debate. Diameter also varied, but was unrelated to other metrics. Here are Lincoln's important words by debate. And here are the word ranks summed across debates. We see that say had the highest centrality, followed by judge. Here are the significant correlations between word ranks. We see that Trumbull and Bill were positively correlated, and say and judge were negatively correlated. Here are the word ranks across debates. Judge and say take turns being the most important word in Lincoln's speeches, and Trumbull and Bill both become important in the 4th debate. Overall, we see that density and average clustering varied across debates and were positively correlated. Diameter varied, that judge and say alternate being the most important word, and Trumbull becomes important in the 4th debate. Now let's compare the two debaters. At the top, each topology metric is plotted across debates for both debaters. At the bottom is a scatter plot of debate by topology metric for each debater. As we can see, there is no obvious relationships. And we see that indeed there are no significant correlations between debater topology metrics. Here are the important word rankings summed across all debates for each debater. We see that state, right, Lincoln, and party were more important in Douglas's speeches, and judge and say were more important in Lincoln's speeches. Slavery and Trumbull had similar importance for both. For research question 1, does the structure of each debater's semantic network change across debates? The answer is yes. For Douglas, we saw that edge counts and diameter varied across debates, and they were positively correlated. Diameter also varied across debates. For Lincoln, we saw that density and average clustering varied across debates, and they were positively correlated. Diameter also varied across debates. For research question 2, are the semantic network structures of the debaters related? We saw that there were no significant relationships between topology measures when comparing debaters. These results are limited, however, due to the small sample size of 7 debates, which gives these statistical tests weak power. There is some anecdotal evidence for the debater's language adapting during the debates, however. It was noted previously that the diameter of Douglas's semantic network was shorter when he spoke first in the debate. He could be adapting his strategy to the format of the debate. Lincoln also seems to adapt based on debate format. His most important word, when Douglas goes first, is judge, which he uses as a reference to Douglas. However, it is say when Lincoln goes first. Lincoln may be on the attack when Douglas starts out a debate,
but when Lincoln starts out a debate, he may be more focused on his own arguments. Both candidates seem to shift focus on Trumbull in the fourth debate. If you inspect the fourth debate, both candidates interact considerably with the sitting Illinois senator named Trumbull, and this is reflected in the structure of their language. Lastly, both candidates stop making the other candidate's name central in their arguments and shift to more policy words, such as slavery, right, and people, towards the last few debates. In conclusion, semantic network analysis applied to historical speeches has potential to help explore the structure of a politician's language and help analyze political messaging quantitatively. Future research will need to look for data with larger sample sizes or use more powerful statistical tests to gain more robust results. Also, comparing two semantic networks over time will require additional methods than utilized in this research. Here are my references. Thank you.